So, welcome everyone at this third seminar of the series that celebrates the 125th anniversary of the American Physical Society. My name is Margriet van der Heijden. I work at Eindhoven University of Technology, and I'm a member at large of the Forum on the History and Philosophy of Physics of the APS. And I am very pleased to welcome for you Frances Hellman, who is a professor of physics as well as was the former dean of the physics department of the University of California in Berkeley. And Professor Hellman has been a long time a member as well as fellow of the APS and a former president in 2022. She was also in the past chair of the division of material physics of the APS, and that's related to her own field, which is that of condensed matter physics, where she studied the thermodynamic and temperature dependent properties of novel solid materials. And in that respect, she's also, or in that property, she's also connected to the LIGO experiment. Quite interesting. Tonight in her talk, Professor Hellman will focus on something else, the women at the APS, and especially also the women throughout the history of the APS. And I very, very gladly give the floor, or rather the screen, to her now.
Okay, thank you, Margaret. Let's make sure that I can share properly. And okay. Is that working?
Yes.
Great. Okay, so I am indeed, thank you very much, Marguerite, and thank you all to all the attendees. And I am indeed partially in my role as past president of the American Physical Society. I'm going to talk about a brief history of women in APS. And I'm going to start by giving you some relevant statistics for women in physics in general, that I'm going to talk about some relevant history of the APS. I'm going to make some comments on other underrepresented minorities, including intersectional groups, such as, women of color in APS and more broadly, and gender minorities. And then I'm going to close with some personal comments and thoughts on why we remain so underrepresented. So let me start by giving you some statistics. So these are 3 plots showing the percentage of women in physics up to 2003. And I'll comment in a minute what happens after 2003, but I want to start here. So the leftmost plot shows high school, which is starting from 1987 up to 2001. And you'll note that the percentage of girls in physics in high school is almost 50%. So it's not changing very fast, but it's also, 50%. The middle plot then shows what happens and what has been happening in the bachelor's degrees, again, starting from this case from 1972 up to 2003. And what you see is that the number of women receiving bachelor's degrees in physics and the number of women receiving PhDs in physics are low compared to the 50% in high school, but increasing pretty rapidly. I mean, it goes from under 8% bachelor's degrees to about 24% in 2003, and the PhDs from less than 4% up to 17 or 18%, with a sharp increase right at the end, which may or may not, which we'll come back to. If I then, that was the bachelor's and PhDs. Now, if I compare the percentage of PhDs earned by women in select STEM fields, that's the rightmost plot. Again, now this plot is from 1958 to 2003. And you see that this rise in the percentage of women in STEM fields is mirrored in all of the STEM fields. I want to note that physics and engineering are the dashed blue line and that solid orangish line down at the bottom. So, so physics is lagging everybody, all the STEM fields, except for engineering, which is comparable to us. So we are seeing an increase. But, for example, in the biological sciences, they're up to almost 50% by 2003, whereas we are still down at, sort of down at the 15% level. And again, that was PhDs. So it's a little alarming that we're so much lower, and it's not completely clear why. So if I now continue with other statistics about women in physics, again, up to about 2003, the leftmost is actually, in this case now, a chart. It shows faculty positions held by women in physics, in specifically looking at 3 dates, 1994, 1998, and 2002. And not surprisingly, perhaps, if you start with the full professor level, it's 3% and then goes up to about 5% by 2002. Associate professor is higher, so 8% up to 11%. Assistant professor higher still, 12% up to 16%. Instructor and adjunct professors were not monitored in those early years, but is up to about 16% as of 2002. And there's similar statistics for other ranks. So women in academic ranks are low percent. And in fact, they're significantly lower than the other statistics I just gave you. But the rightmost figure is a plot showing that if you actually stop for a minute and don't just ask the percentage as a snapshot in time, but ask the question of, given the bachelor's degrees in physics for X number of years, there's the blue line is the actual values of all these things, and that orange line in this rightmost plot shows what would be expected based on the percentage of bachelor's degrees in the past. So in other words, you're not going to expect to find more professors in physics than there were bachelor's degrees 10 years before that or something like that. So this is a time shifted plot and shows that in reality, women disproportionately leave physics between high school, where it was about 50%, and earning a bachelor's degree, where it's down to more like 20% or so. And after that initial leak in the physics pipeline, women are actually represented at about the level you would expect based on the degree production in the past. And I'm going to make one more comment on that in a little while. But for right now, the takeaway message is, if you wish to think of a leaky pipeline, the leaky pipeline is occurring in between high school and bachelor's degree. Okay, so first takeaway, this is as of 2003. And in the 2005, there's a report that got a lot of traction and a lot of citations and so forth by Ivy and Ray in 2005, an AIP report on women in physics and astronomy. And I'm just going to quote directly from that report. First quote, although women's participation in higher education overall has now passed the 50% mark at the bachelor's level and is approaching 50% at the PhD level, women, that's overall, higher education overall, women earned just 22% of physics bachelor's degrees and 18% of physics PhDs in 2003, which was at the time a record high. Women's participation in physics is increasing, although slowly, and the rate of increase has not kept pace with other fields. One field that is notable for having a much higher representation of women is astronomy, which of course is closely related to physics. Second quote, another issue of concern about which we have no data in this report is the effect of the climate for women in physics, which in some departments is very chilly. The climate speaks to the everyday work life of female physicists who are often still told through actions, if not through words, that physics is a man's world. Although many departments do not have chilly climates and are working to improve the conditions for faculty and students, better data are needed to document the conditions so that effective practices may be established to correct unwelcoming climates where they exist. I quote these, even though it's from 2003, because much of what's said here in this 2005 report could be equally said today. And so that's slightly alarming that the situation is not that different. So I will come back to that. Okay, now I said I'm going to make some comments on other underrepresented groups in physics. So let me turn briefly to underrepresented women in physics. And so the leftmost figure shows African American and Hispanic American women receiving bachelor's degrees, again, in this time frame from up to before 2005, so 1995 to 2001. And as a note, in that period of time, 95 to 2001, there was approximately 3,800 physics bachelor's degrees per year in the United States. So of that 3,800, approximately 50 are African-American women, and approximately 20, growing rapidly, notably, the African-American representation seems to be modestly constant, within the noise. A Hispanic American started off extremely low, but is climbing rapidly. But these are actual numbers. This is not a percentage. I want to make sure that is clear. This is a number, not a percentage. The percentage is, of course, extremely small. Now, if I turn to the PhD representation, that's on the right-hand side, This is now the number of Hispanic and African-American female PhDs in physics, all the way from 76 to 2003. So African-Americans, you can see, this is the total number in each time segment. So this is from 76 to 82. There were three African-American women who received PhDs. So in a 6-year time period, there were 3 African-American women. And that changes to 4 and then 8. And then by the time the most recent pre-2003, 1997 to 2003, a total of 20. And then we see similar statistics for Hispanic American women. And so the bottom line of this is, again, those are not an average, these are total. So the bottom line is between 97 and 2003, an average of fewer than 3 Hispanic women and 3 African-American women earn PhDs in physics in the US each year, out of more than 1,100 PhDs awarded in physics each year. So 3 number, I mean, you can calculate the percentage, but of course it's tiny. Okay, so alarming statistics, and the gender issues and race and ethnicity issues combined together to make a particularly well, appalling is probably a good word, set of numbers. So here is some. Now I want to turn to since past 2003, because this was notable. A notable thing is going to happen there. So the left plot is similar to the plot you saw before, which stopped at 2003. And you'll notice if you look hard at it, the PhD has that little upward kink that I noted back on the slide that ended in 2003. The sort of alarming part here is that after 2003, the percentage of women physics bachelor's degrees actually dropped between 2003 and 15. So any optimism we might have had back in 2003 with the numbers and the percentages increasing is undermined pretty seriously by this plot, which shows a leveling off, possibly an increase right at the end, in the bachelor's degrees. Again, sometimes could easily be just a noise result. So an interesting note is that, and I show this on the right, if you dig in a little deeper and you don't ask just the percentage, but you ask the raw numbers, what you find is that the number of women physics bachelor's degrees continued to increase. That is the bottom line on the right side. So the number continued to go up, but the number of men went up even faster. So the number of men in physics, except for the very last data point in that right-hand plot, went up. And so that very last data point where the number of men dropped a bit then explains, why there's a sudden jump in the percentage. So you have to be careful when you're looking at percentages. To try and understand causality, you have to look both at percentages and at raw numbers and then attempt to interpret. So I would suggest that this optimism that we had very naively, if you took the data at 2003 and extrapolated it, we should be up at like 30 or 40% by now. And we're not. So let's now look at statistics on physics compared to STEM more broadly. And so that's on the left-hand plot. You see physics in blue right down near the bottom. You see engineering in kind of yellowish color, which is similarly right down near the bottom, along with physics, and computer science similarly right down at the bottom. And the bachelor's degrees, there is a similar plateauing across STEM. This again is a percentage, not a number, but a similar plateauing in all STEM fields. But the numbers are just much larger. In biology, they're up over 62/3 women at this point. And chemistry is similarly now up over 50%, et cetera. So, and again, on the right, I'm showing you the actual numbers so that you have both sets of data in front of you. But the bottom line is the percentage of women's bachelor's degrees dropped in all STEM fields from about 2000 to 2015. Then there's been some recovery, but physics and engineering seem to be kind of stuck between 20 and 25%, while other STEM fields are 40 to 60%. And again, the number of women in both physics and STEM overall increased, but the number of men are increasing faster. So let's look at this data in a different way. And so this is a plot attempting to get at this leaky pipeline idea. And I put this in quotes because personally, the leaky pipeline is it's not really a framework that I like to use, but it is a framework that is familiar to people. So what this is showing is in a set of STEM fields, so specifically at the bottom, you'll see biological sciences, chemistry, math and stat, astronomy, engineering, physics, and computer science. And it's showing the percentage of bachelor's degrees in blue, master's degrees in green, and PhD in red. And what you see is that in the biological sciences, there is a significant drop at each of those stages. And in other fields, sometimes the master's is higher, but in most fields, there's a significant drop. Now, in astronomy, it stays flat. So the percentage of women does not change substantially across these different degrees. And in physics, there's a slight drop in the PhD, but not that high. And so, in fact, the conclusions that seem evident from this data is that the biggest drop occurs pre-college and in high school particularly. So again, the numbers in high school are up near 50%, and then the drop is between high school and bachelor's degrees. And that's where the drop is occurring for physics. And I want to make an additional comment, and this is based on the data that I took while I was Dean of Mathematical and Physical Sciences at Berkeley, which is we dug into the drop during college. So the AIP reports focus on bachelor's degrees because that's the data they had. But we have a lot of data on entering intentions versus declaring major. And what we find is that there is a big drop so we all know that the drop occurs between high school and bachelor's degree, but I would suggest that it is likely that the biggest drop actually occurs in the first 2 years, at least in large schools like UC Berkeley. Those first 2 years in these large intro classes with not much departmental support, at least at a large school, because they haven't even declared a major yet in a liberal arts school such as the College of Letters and Sciences at Berkeley. Those first 2 years are, I would suggest, where the drop actually occurs. And so I pointed that out to AIP, and I think they're considering how they might try and address that question. So it's a little more fine-tuned than just between high school and college. All right, so let's go on. I'm going to touch on the topic of intersectionality. So this is a plot now of bachelor's degrees in physics. And this is for different ethnicities and race, but men versus women. So on this plot, each one of the bars totals to 100%. And then the numbers that are shown inside each bar are the actual numbers. So let's just start with, let's start on the far right with the white bars. So the white bars show that there is sort of 75% men and something down around 20% of women getting bachelor's degrees in physics. So this is of white people. The total numbers are 4,526 of white men and 1,248 of white women. So this is essentially the number that we showed you before, about, sort of 20% roughly of bachelor's degrees. What you'll notice now, so going from the white column on the right to the other various types of ethnicities and race, what you notice is the numbers are, they get very small by the time you get to the indigenous native peoples numbers, but the ratio is about the same. So the percent of women in each race ethnicity is actually similar. So that's an interesting observation. It does not seem, it's not like in other, Black Americans, there is still a big disparity in gender, in addition to the fact that there is a disparity based on race as well. So more than one issue. And none of that touches, I want to note that I do not have statistics in this talk on low income, but there is lots of evidence that low income matters even independently. There are obviously cross correlations between low income and gender and ethnicity and things like this. But as an independent variable, the statisticians are very clear that low income is a separate determining factor that leads to just low representation. Okay, so turning now specifically to the participation of underrepresented minorities in physics. This is the percent, so across the board in college-age population is the leftmost column, and then all bachelor's degrees, URMs, underrepresented minorities, is down at sort of 20, a college-age population is almost 40%, college degrees is 22%. So half. So there's a problem, with getting underrepresented minorities to their college degrees. If I then look specifically at physics, we're down at 10%. If I look at physics PhDs and faculty, it drops still further. So this is information, if anybody hasn't noticed, then they're not looking very hard, that the representation in physics of people of all types of underrepresented groups are very underrepresented. So this is should be alarming to everybody, I would suggest. Okay, and so just again, there's a 2019 report I want to note, AIP report from Ivy and Porter, and the quote from there: African American and Hispanic women remain underrepresented in physics and astronomy. However, the number of Hispanic women earning physics and astronomy degrees is growing rapidly over time, while the number of African American women has not shown similar growth. So. All right, so I'm going to give you some employment information summarized directly gender related from AIP. So there was a survey of new physics degrees from 2021 and 22 that was combined, and I'm just going to tell you some results from that report. First, no statistically significant difference in initial outcome for new physics bachelors, where the choices continuing with graduate study or entering the workforce. So men and women statistically continue about equally. They're disproportionately, that's not to say there's equal numbers of men and women, but starting from the numbers that of physics bachelor's degrees, they proportionately continue with graduate study or enter the working force. For new bachelor's degrees immediately entering the workforce, women are more likely than men to be working at a college or university or at a high school. Men are correspondingly more likely than women to be employed in the private sector or in the military, and that does not include graduates from military academies. Among the employed, men are more likely than women to be in computer science or information technology and engineering. Women are more likely than men to be in physics or education. And that partially reflects these different employment sectors that, men more likely to go into private sector, women more likely to go into academia. Men are more likely than women to have long-term private sector career goals. And then among new physics PhDs, women are more likely to accept a US postdoc than men. These are not very large statistics, but not very big different statistics, but somewhat. And then new PhD long-term career goals, academic employer versus private sector employment, the same sort of statistic as we've already seen. So women more likely to go into academia, et cetera. So interesting employment information, which may impact their studies as well. So. Okay, so now I want to turn to the topic of women in APS. So I'm now showing all the way up to 2024, the percentage of women members in APS, which back in 2010 was down near 10% and now is up over 20%. And in not showing the same leveling. So, women, I'm going to start by noting this because I think APS is actually doing a pretty good job of attempting to recruit women members. This is partially reflects the fact that women are more represented in younger cohorts, but overall, still, the number of members seems to be going up, seems to still be climbing. I want to show you some interesting photos. This is a photo of the APS in 1909, the upper left, which is taken at the University of Illinois at Urbana-Champaign. And just notable in that picture is, I'm pretty sure there's only one woman in that whole picture. Of course, there could have been some transgender person cross-dressing, but I suspect that is a vanishingly small group back then. So one visibly evident woman in 1909. I then turn to the bottom picture, which is the participation in the 50th anniversary meeting of the APS at Harvard University, which is in 1949. So 1949, well, you're now starting to see a reasonable number of women are now visible in this picture, although still a very small percentage. And then I want to note a picture I found, which I just thought was sort of charming, from 1972. This is the first CSWP, which stands for the Committee on the Status of Women in Physics, their first meeting in 1972. And so that was when CSWP started. And just thought it was a lovely picture showing both men and women, by the way. Okay, so continuing. Now, there's an interesting, this is again a brief history of women in the APS. And so here I show APS presidents from 1899 to present date. And I just added the two most recent ones at the top, and I've highlighted the women in yellow. So what you see is in the early years, all the way from 1899 up to 1974, there were none. Then C.S. Wu in 75, and then you see Millie Dresselhaus in 84, then you see Miriam Sarachek 2003, Helen Quinn 2004, Cherry Murray 2009, Laura Green 2017, myself in 2022, Youngki Kim in 2024, and Gabrielle, most recently, Gabrielle Gonzalez will be the president. She was just elected vice president. She will be the president in 2026. So statistically, we go from 0% all the way up to 74 to now, if I look at from 2003 to date, I see 29%. So APS is trying hard. I think they're doing a pretty good job of recruiting women into the presidential line. And of course, one could conduct a similar study of the unit unit chair lines and things like that. But at least at the highest level, this is the statistics. So if you look at unit demographics, there is a nice APS website for 2023 data. What you find is that it is overall 21% women. That's consistent with what I said before. But you will find that some units are only 11% women, while others are more than 25%. And so I decided not to call out the low percentage units. I will let you go find which those are. But the high percentage units are astrophysics, biophysics, polymer physics, medical physics, physics education, and quite a few forums. So there is an interesting disparity, and those of you, maybe you want to go look up your own units and figure out how well you're doing. It's also notable that the percent of women fellows is comparable to the percent of women members in most, but not all units. So again, you might want to take a look at your own unit to see what you find. Turning a little bit to gender diversity, and so this is data, this did not used to be collected, but in 2023, what you find is that non-binary members, these are those who self-declare, by the way, so or declare, many don't declare, but non-binary 0.7%, non-binary early career members 1.2%, non-binary students 1.7%, and 8% did not specify. So there is a growing population as we turn to the younger members of APS that are calling themselves non-binary. Overall US population, apparently 1% of adults identify as non-binary, but 3% of young people under 30, 1.3% of 30 to 50-year-olds and 0.1% of 50-plus-year-olds identify as non-binary. So that's somewhat consistent, but again, we are underrepresented relative to the overall population, but we're at least tracking that. Okay, so if I turn to diversity in APS membership and other characteristics, the numbers are all shown here. And APS membership is far below the general population in absolutely all URM categories. And so not surprisingly, we're very underrepresented. Okay, so what has APS done to try to address the issue of low representation in physics? And the answer is quite a lot. I want to quote from the former APS CEO, Kate Kirby, gave a talk on this not too long ago. The physics workforce is not diverse. I don't think I'm going to surprise anybody with that statement. This has been a longstanding problem and a concern of APS for over 50 years. The lack of women and gender minorities, the lack of individuals from historically underrepresented groups, and I list those that are that are typical to be considered in those groups. Some early initiatives, the establishment of two APS committees. There was the Committee on the Status of Women in Physics, CSWP, which was established in 1972, and the Committee on Minorities in Physics, COM, established also in 1972. Some early programmatic activities in APS focused on diversity. Climate site visits. I'm hoping some of you already know about climate site visits. When I was department chair, we took advantage of this program. This was started by Millie Dresselhaus and Judy Franz, who was the CEO, wasn't called CEO at that time, but and they do about 3 to 7 of these a year. There's a bridge program, which was started in 2012. The Conferences for Undergraduate Women in Physics, QWIP, which I want to note is now called Q-STAR. I guess that should be a lowercase I, but Q-STAR IP, which was started in 2011. And overall, in everything that the APS does, we attempt to seek advice and oversight from APS members and assessment of programs. More recent APS activities, you may have heard of the APS Inclusion, Diversity, and Equity idea, which was an APS Innovation Fund in 2019 with initially 97 teams with about 1,200 individuals looking at with U.S. and international academic institutions, including Hispanic serving institutions, historically Black colleges and universities, national labs, and collaborations continuing to grow. So that's a very active program. Effective practices for physics programs, EP3 guide. If you don't know about this and you are working in academia, you should find this. It includes best practices in equity, diversity, and inclusion. And it's a wonderful and still growing guide. Grants for undergraduate women in physics. The Forum on Diversity and Inclusion, FDI, was started in 2020 with 1,600 signatures. At the APS, and I'm talking, at APS meetings, there's a professional skills development workshops, there are childcare grants. There is a program known as Step Up, which is designed to support research-based curriculum, classroom strategies for high school teachers to encourage girls to study undergraduate physics. And that's a program that is supported by a variety of foundations and so forth. So that Step Up program is focused on trying to get girls who are interested in high school to think of this as a long-term career. Okay, those programs focused on underrepresented minorities. There's the National Mentoring Community, which is about mentoring relationships. There's the APS Bridge program, which provides underrepresented minority post-baccalaureate students with research experience, advanced coursework, and coaching to help prepare them for graduate school. Climate site visits. I talked about the women, but there's additionally, that's a broader thing. Something called the Inclusive Graduate Education Network, IGE, and attempting to increase the participation, again, just working at graduate level. And then the idea, which I already mentioned, which is this network of students, faculty, and researchers who are trying to implement research-based transformational methods to drive cultural change and center people with marginalized identities in 100 academic departments and laboratories nationwide. And finally, the task force to elevate African-American representation in undergrad physics and astronomy called Team Up, which is a partnership with AIP, started in 2020. I've already noted that some African-American representation in physics really seems to have gotten stuck at a very low level. Okay, so changing the physics culture. Well, let's see. How do we change the physics culture? This was referred to back, I told you I was going to come back to this point from the early Ivy report back in 2005. So the challenge is it involves changing our behavior. We have to be more self-aware. We have to ensure that we engage respectfully with each other. Cooperation and collaboration instead of competition. Pay attention to what you love about physics. It doesn't have to be a giant rat race. There are other APS initiatives which are attempting to support change. We have recently adopted and are working on implementing an APS code of conduct at meetings, which is out for member comments now. Development of an APS ethics guidelines, which has been expanded from early focus just on scientific integrity into something a little broader, and that's out for comments from members now. So if you don't know that you have an opportunity to weigh in, please find those. So I will leave you with, I'm going to leave you with two comments. One is, what else can we, APS, do? And I think that's a thought process. We welcome comments in the chat window, what you think we can do. I want to note there is a website at the APS, which has a lot more information. And I'm just going to leave you with a couple of personal reflections because I've been in this field for a long time. And I think we all optimistically thought that the number of women was growing and was just going to, was being a little bit slow. We would have all liked it to be a little faster, but it was growing. And I'm worried that that's not true. The evidence, we'll see what things look like. It takes years to really look for change. But I am worried that our chilly climate is still the prevalent climate most places. And that the reason the numbers are not changing is this chilly climate. And that's a very difficult problem to address. I'm using some relevant buzzwords because they're not really buzzwords. They're relevant issues. Things like stereotype threat, implicit bias, what's the word? Sorry, I'm missing the word right here. These are all meaningful things and leave people feeling like they're not good enough to be in physics. And there is a gender element to this, to all of this. Imposter syndrome, that was the other word I was looking for, is imposter syndrome. So I will leave you with a final thought on the whole imposter syndrome thing. I had a really very, very talented, I've had a couple of very talented women graduate students in my own group. And they got out of traditional, in fact, it's more than two. They've gotten out of traditional physics research, and some of that was the chilly climate. Some of it was this imposter syndrome issue, where they just did not believe that they were good enough. And I will add to that, I'm at a point in my career where you would think that imposter syndrome, I mean, I've been the president of the APS, I've been the chair of the physics department at a major research institution. I was asked to be the dean, et cetera, et cetera. But there are times when I look at my own self and think, wow, I'm not sure I'm good enough to be doing this. So I asked that question of the group when I last gave this talk at the March meeting this past year. And I asked the question of the group, how many of you have had imposter syndrome or felt that imposter syndrome has caused you to consider not being in physics? And over half the room raised their hand. And included in that were men and women. So anybody can, it's absolutely possible for men also to have imposter syndrome. It's just less prevalent. And they speak of it less. So it is, much more, I guess, socially acceptable for women to have imposter syndrome and talk about it, less socially acceptable for men. Nonetheless, it impacts everybody, and it impacts our field. So we all are part of this, and we all need to do what we can to change the climate. So I will end at that and ask and open the floor up for questions. And I think I will stop sharing also. Let's see.
So thank you very much for a wonderful and inspiring, and also sometimes a bit, I was a bit shocked sometimes by the number, especially by the stagnating effect and even the drop between the years 2003 and 2015. Are you aware of any research that has been looking into reasons to explain this effect?
You mean that it seemed to be going up and then it seemed to have leveled out?
Yeah.
There is competing. I think, the problem. So one problem with all of this is I am not a sociologist. I can't even tell you how many times I've been asked to be on gender equity studies and how do we solve this? And I keep saying, look, I'm a condensed matter experimentalist. I know how to think about complicated materials. The materials I work on are amorphous, not crystalline. That's complicated. But that is a lot different than looking at sociological questions of things like our chilly climate. So my best interpretation is that there are multiple reasons for all of this. There's multiple reasons that, there's not going to be one answer because there are multiple causes. So the fact that the number of women kept going up while the number of men went up faster, leading the percentage to drop, probably has as much to do with economic conditions as anything else. That that the economics, it's hard to get it if there's a big downturn, a recession, then the people tend to go to graduate school because they didn't have a good career option. So there are many sources of all of this, and so I don't think there is clear evidence of what happened. Some of it was clearly the recession. I think
Yeah.
there's going to be a big impact recently from COVID. And unfortunately, I think there may even be differential impacts from COVID. And so, so this takes careful study, and I don't know that I know the answer, but I'm absolutely sure there's more than one cause, and there will therefore need to be more than one solution. Yeah.
Yeah, thank you. It's an intricate problem. So let's see in the chat. There's a question from Cheryl Spencer. any ideas why women do better, in quotes, in astronomy departments than in physics departments?
That is a brilliant question. And now I'm just going to do armchair psychology for you. So, you should take this. I literally am not a sociologist. So, you can take my armchair psychology as worth absolutely nothing. Um, I think there is so again, I hesitate to say this, but I do think that women thrive more in cooperative instead of competitive environments. Um, and there is a way in which this field of astronomy has these large, is a lot based on observational science. Um, so that is 100% speculation. They do seem to do better. They even do better locally. If I look at my own astronomy department here at Berkeley compared to my physics department here at Berkeley, there's more women in the faculty, there's more women in the graduate student population, and you can ask the same question about biology. Like, why is biology doing so much better? I'm going to
Mhm.
use the adjective better, because I think it would be better if there were more women in physics. And why? Well, some people have speculated that's because it has an impact. Women like more to have things that have impact on the world, and less pure ideas and more impactful ideas. That would be fine, except for there's funny things in math that don't completely jive with that. So I guess I would say any speculation we have, any armchair psychology, if we're going to be good scientists, we should think of how can we test that hypothesis? So, why would math was, particularly for a while, doing better? And that, I'm not sure I see greater application of mathematics than physics on the real world. So any speculation about biology being more more relevant, more societally relevant, I think that's questionable. I mean, yeah. So,
Yeah.
so I think your ideas of why are anybody, again, this is armchair psychology. I'm not particularly equipped. I've spent
Mhm.
a lot of years thinking about it, um, but I don't know that I'm any better equipped to answer the
Mm.
question than anybody in this talk today.
What was very striking during your talk was um, this big drop in the participation of women between high school and college, yeah, or during pre-college. And there's a question about it from an anonymous attendee. How can we help bringing physics in the high school curriculum across the 4 years of schooling? And the remark also goes with that. Currently, there are states that require little to no physics in high school.
Right. Right. And so there's actually a two-part problem here. So one is women deciding thinking they might want to major in physics when they enter college, and then actually completing their college degree. And and I know that's a two-part question because we had to answer that here at UC Berkeley. We know that the entering number of women and and the number of underrepresented students is dropped. So there's fewer entering and they drop out.
Yeah.
So, and the one of the reasons I stress the intersectionality issue is if you try and get statistics for women leaving STEM, underrepresented women leaving STEM, underrepresented women of low income leaving STEM, they are multiplicative factors. And so I mean, that's probably not a technical term but loosely speaking, it's multiplicative. So, loosely speaking, at least if I quote, I can talk about at Berkeley, 2/3 of white males who enter intending to do a math and physical sciences degree complete a math and physical sciences degree. Half of white women, a third of underrepresented people of both genders, and if you ask the cross section of the underrepresented women, they won't even give me the statistics because you're down to countable numbers. I mean, you
Mm.
could actually identify. I mean, it would be
Mhm.
people, and so you could identify them, and they will literally not give me the statistics. But loosely speaking, it was a third of underrepresented overall, and of that, we already know it's only about a third of that of the under of women of color. So you're at about a ninth. So even though the numbers are low entering, and by the time they're done, you're down to a ninth of them, roughly. And that's just a vanishingly small number. I mean, to some extent, yeah, to some extent, you're saying none of them finish. I mean, it's only a few people different from none. So it is a horrifying statistic. And again, I point to the interesting thing, at least at my institution, once they declare a major, this leaky pipeline thing does not happen the same way. So the leaky pipeline really is in, for us, at least the first 2 years. And I would, possibly true at other institutions. I obviously can't speak to other institutions, but once they declare, we are paying attention and we do tend to hold on to them. So the problems really are occurring in these, large intro classes where people get lost or they feel, the imposter syndrome stuff starts coming in. There are studies of, men and women do equally, let's call it mediocrely, like let's not go all the way to badly or all the way to well, but they interpret it completely differently. So, a man gets a 50% on some, test, and he thinks, oh, the professor was a horrible person and gave this horrible test. That's all they think. Like, I got 50%, but that's because the professor was horrible. I'm being polite in my wording here. Well, the woman looks at it and goes, I'm not good enough, and quits.
Yeah.
So how do we, I mean, and I will say a very controversial thing here, which is every now and then it occurs to me that the issue is not that women are leaving physics, but that why aren't men? So that man who got a 50%, why is he so sure that he should still be doing this? Because there seems to be an overconfidence level in men that,
Yeah.
and that is a gross overgeneralization. Because many men have the same issues of feeling like they don't deserve success, et cetera, et cetera. But nonetheless, statistically, men stay in at exam results that cause women to get out. And I don't know which one's right. I mean, who knows which one is right to leave, but
Yeah. So we have overconfidence on the one hand and imposter syndrome on the other hand, and there are perhaps two sides of the same coin. This
exactly.
relates with,
Exactly.
yeah.
Our society tells men, so rather than, I mean, I'm not trying to be disrespectful of men. Our society tells men they need a career. They need to have a career. Staying home to raise children for a man is actually harder than staying home
Yeah.
for a woman, or less socially acceptable. So they're trapped too. I mean, everybody is sort of trapped by stereotypes.
Yeah. Yeah. And so related to this entanglement of imposter syndrome and feeling lost perhaps during the first 2 years of college, there's another question by Christine Louis, if I hope I pronounce it correctly. Given that 2-year colleges have much broader diversity in gender, race, socioeconomic age, etc., in their students, and the idea that we are losing women in these first 2 years of college, what is APS doing to support 2-year college physics instruction?
That is a great question. And I'm not certain I know the answer. So I don't want to answer that question without being sure that I know. I do know that APS is pretty deeply engaged in discussing with AAPT. And I would suspect this topic comes up. So we all are aware that the 2-year colleges, and in California, there's a whole transfer system. We're supposed to be taking community college students and bringing them into the 4-year UC system quite specifically. And the representation in the 2-year college system is indeed much, much better. Now, helping them to transition is its own issue. You go from being the top of your class to being not the top of your class once you make that transition quite, rather generally. You're much more competitive and, well, again, the word competition. This should not be a competition. None of this should be a competition. So I think it's a great question, and I will relay the question to APS to see. I think it's a very good question what they're doing with
Good, thank you. There's also a question from Todd Fansler. You mentioned that site visits are one tool being used to address diversity and the lack thereof. How are departments selected for such visits, and how are they received by those which are visited?
Great question. Those two questions are actually coupled to each other because they are not selected, they ask. So I know this firsthand. So when I was the department chair, I reached out to APS to ask if they would conduct a site visit. And the way that works is APS picks up some of the cost and the department picks up some of the cost. And so how are they received? Well, to some extent, that's self-selection. I mean, at Berkeley, like I asked for them to come in and then we used their suggestions and their outcomes because we were already interested in that result. And of course, the worst behaving are not going to ask. So they're not selected. They are, they have to be requested.
Yeah. Yes. And then there's a question again from an anonymous attendee. Do you have a sense of the state of women in physics worldwide? Which is interesting also, right? For comparison.
Very interesting. And I don't have the statistics at my hands. It's actually, if I was giving this talk again, I might have tried to include that. I do know that it varies very widely. So we are anomalously low, but we are not the lowest. Do I want to, I recently had, well, let's see. Let's just leave it that I have found there are countries in this world which are much lower than us, like
Mhm.
8%, which I discovered for reasons that I would tell somebody privately, but I'm not gonna publicly call out here. As I said, it's better to publicly call out the positive ones and let the negative ones people can look into them themselves. So there is a wide range internationally, and down as low as 8% in some countries and as high as, I think it's 25, 30, 40%, 40%. And I'm trying to remember which of the countries that are high. There are some European countries that are quite high in women, but there's also some funny ones, like maybe Russia or something like this. And I think there may even be a correlation with the salary scales, like places that people are, this I know shows up in the medical profession. I think it also shows up in the physics profession. So somebody should really check my numbers on this. But there is a correlation that where women are, where the profession is less highly paid, there are more women. And in our country, we see that with like grade school teachers.
Mhm.
That's
Yeah.
the majority of grade school teachers, and they're not very highly paid. But it's also seen in professions, like in our country, doctors, different types of doctors. The pay scale has a kind of unholy correlation with the percentage of women. So
Yes.
I don't know what's cause and what's effect there. That would be an interesting question to ask also. So internationally, there is a big disparity on different countries. And so there may be something to be learned from that.
Yes. Well, I come from Europe. I come from the Netherlands. The Netherlands is not doing that great within Europe. And I think it's true what you say, like in countries like Italy, France, or Spain or Greece, you find more women in physics. And some people say that it might be correlated to salary indeed. Although some have also said it is correlated to Catholicism versus Protestantism in the Netherlands and Germany. So it's a complex problem.
It is.
But there are many more questions, in fact. So I would like to go on with the questions from the chat. What subject and that's also quite interesting, I think, what subject do the women undergrads change to when they drop out of physics?
Great question. So that's a moving field. That's a moving topic. So one of the places they go to is things like computer science and data science. And you could even, none of this, one should be careful not to have judgments about it. Like it isn't necessarily bad that they dropped out of physics.
Mhm.
It's not, I mean, the judgment is not really helpful for any of all the women I've known in my career who've gotten out of physics. They all did so for very good reasons. Each one of them did so for very good personal reasons. It wasn't like I would tell them they made the wrong decision. So the question one could ask is, are they dropping completely out of STEM, or are they just switching, for example, from physics into something like computer science? Or somebody asked earlier about, oh yeah, here's the next question is about earth science. So
Yeah.
earth science is an interesting one because nobody in high school thinks of earth science. They may think of climate change. So the world may be changing pretty quickly. In that climate change is becoming more and more a topic. And so therefore earth science may start benefiting from that. But in high school, people don't take earth science classes in general. So they don't enter college necessarily thinking of that as a major. So then in the statistics I was giving about Berkeley, we didn't actually do physics separated out. That was math and physical sciences all lumped together, which included earth sciences, by the way. But if I dig down a little deeper, I do know that earth sciences, like astronomy, does quite well in its representation of women. And so again, we can ask why. Not sure I know why. Maybe again, more relevance, more impactful on society. That's the armchair psychology sort of stuff. But I do know that earth sciences is like astronomy in terms of their representation of women. So Cheryl's question about what happens when they drop out of physics degrees, some of them have gone into like computer science and so forth. Interestingly, they don't tip in the statistics I know of Berkeley, so this may be generalizable or may not be. They don't drop out completely. So they don't leave college, they just switch degrees. And so again, one needs to dig in more. They may have made perfectly reasonable judgments of what was best for them, but they also may be making decisions. I mean, their parents lean on them to be a doctor, or their parents lean on them to be an engineer. So quite often, if you're going to deal with a problem with college age people, you have to factor in what pressures are they getting from their parents.
Yeah, it brings me to a question I had myself about the leaky pipeline. You said that you didn't like the leaky pipeline frame too much. And I was wondering whether this is related to this sense that it gives that you drop out, or whether you have other objections against the frame.
I don't like that. Well, because the phrase leaky pipeline suggests that the solution is to plug the pipeline. So the solution to the leaky pipeline is put your, be like the little boy in the dams, put your thumb and stop women from leaving. So I don't like I don't like that analogy. The point of this isn't to stop women from leaving. So that's the first objection. The second objection actually to the term dates back in my career to oh my gosh, 20 years ago, at least, probably 30 years ago, when I heard a woman giving a talk on education, and she said, and she was the one who started me thinking. She doesn't like the term leaky pipeline. She calls them pathways, because the thing about a pipeline, it implies that what you have to do is people start in a pipeline, and then you want to keep them in all the way through till the end. Whereas the term pathways suggests that there are multiple ways in. And you don't have to have stayed in a pipeline the whole time. So what you might want to do is provide pathways for people to come back in. And there was a moment when I was a professor actually at UC San Diego before I came to Berkeley, and I was running a women in physics group there. And I wanted to have, I was in charge of the group. And I wanted to bring in somebody who'd taken some years off for child rearing, had taken some years off and then come back to finish their degree or something like that. But I couldn't find anybody in physics who'd done that, at least not at where I was. So I reached out to grad division to ask if they could offer some suggestions. And they gave me two names. They gave me names of two women who had done exactly that, taking time to go have children and then come back to graduate school. So I said, great. So I talked, I had their emails, and we talked. I think we may have talked by phone. Not sure if we even talked by phone, but anyway, I arranged for them to come talk to my group. And when they walked in the door, I was hit in the face with one of my own apparent biases, which I didn't know I had, because they were in their 50s, at least. So their version of taking time off is they had taken time off until the kids went to college and then had come back to graduate school. And I just hadn't anticipated that at all. And the barriers they were facing, grad division knew of them because people routinely would refuse to be on their committees because they'd say, what is this person doing? They can't catch up. And the point they made is, we're not trying to catch up. We never said we were trying to catch up. We just want to get our PhD, and then we'll look for a job. And we're not expecting to get a job as though we hadn't taken 20 years off to have children. We just want a job. So just give us the chance to have a job. First thing is give us a chance to get our PhD. And I thought, this again is one of these evidences of the assumptions that we all make, that they weren't trying to catch up. They weren't trying to get paid or to have a job as though they'd been doing this the whole time. They just wanted to contribute. So Yeah, so that's why the term pathways I find, is a much more appealing idea, and I suspect will be more appealing to people, if they want to take time. I've had a lot of experiences in my years, and I had one time where I had a woman and a man. Um, uh, the woman was in my research group. The man was in one of my colleagues' research groups, but they were basically in the same field of condensed matter physics. And the woman decided she didn't want to finish her PhD because she wanted to have children. And the man decided that he did want to finish his PhD because he wanted to have children. And so he needed
Mhm.
a career to support them. So again,
Yeah.
same data, but they had different interpretations of it.
Yes.
And, you know, there was a fascinating study, again, quite a lot of years ago, but done of the NRL postdocs, what is it? The NRC postdocs, National Research Council, which is a
Yeah.
very high level postdoc, at least I know about this study from a long time ago, but it's very competitive. They get paid a lot, very prestigious. So the people who are being selected into this are high level graduate students then going on to postdocs. And they did a study where they looked at people who, after that postdoc, did go on in careers versus didn't. And what they found is that both men and women dropped out after, some dropped out, both genders, on finishing this postdoc. But women dropped out more, men dropped out less, and their reasons were different. So again, here's the armchair psychology stuff going that I'm going to introduce. No, sorry, that's not armchair psychology. This is not my personal opinion. This is a study. Sorry, scratch that sentence that I just said. This is not just my opinion. This was a careful study. What they
Yeah.
found is that men were dropping out because they thought they could earn more money in a different career. They decided like that academia just didn't pay enough. Women dropped out because of various family reasons. And they ranged. The family reasons were all over the map. Some of them were taking care of their aging parents. Some of them were taking care of young children. Concerns about this, even that they might in the future. But so they had different reasons for leaving. And this is the very top level postdocs. This is not like you're not losing, sort of this idea. So I guess that's another thing I should comment on. Many times people just think that there's a distribution in abilities. So you're just losing the tail end of both. And, now we get back into these, terribly gender biased studies that have been done of IQ in men and women and things like this. So if you assumed that the distributions were skewed and you took the tail off of each, then you would disproportionately take women out. But that's not what's actually happening. So that would be an interesting theory, but it's not true. It turns out that women are dropping out at all levels. Super talented, incredibly talented women are leaving physics. So it isn't that we're losing the least talented and there, is more of them or something, some explanation like that. That's not true. We're losing women across the entire spectrum, including, extremely talented women at the very top of our physics
Mhm.
spectrum of talent. We're losing them as well as we're losing across the board. So it's not a question of innate ability or something like that.
Mm-hmm. Mm-hmm. Yeah. And then it's still hard to disentangle whether they make these different choices because of, for example, a chilly climate, or because of personal reasons, or because of imposter syndrome, or because of all these reasons
Right.
mixed up together.
Yeah,
So that.
and one important point to make is the fact that we don't know the answer to this doesn't mean that there's nothing we can do, because there are
Mhm.
things we can do. In fact, even as women, one of the horrifying statistics is when they look at bias in which shows up everywhere. It shows up in teaching evaluations, it shows up in research, it just shows up everywhere that there are biases. The problem is women are as guilty of this as men, which is a
Mhm.
sad truth. So, it's just true that women are as guilty of bias against women as men are.
Yeah.
And so there's not nothing we can do. There are things we can do. We have to, there's a lot of bystander, being an active bystander. So the term bystander, I have a colleague who hates that term because he said, we're not bystanders. We should be upfront charging in. So, but, when you hear somebody being disrespected, we can politely step in and say something, particularly those of us who are more senior. We are part of the culture, and therefore it is up to us to do what we can.
Yes. So hence also all these APS programs, the mentoring, the bridge program, the climate site visits. Do you have a preference, or do you have a favorite one, or do you have one that you think is really addressing this issue that you now mentioned?
That's such a great question. I don't know, they have pros and cons. Each one of them
Mhm.
has pros and cons. I mean, the bridge program is very expensive. So it takes a lot of money, but it's quite effective, but it takes a lot of money.
Yeah.
So they have to fundraise for that. The step up, and so, and partially the point of the bridge, of these bridge programs is that the underrepresentation is so horrendous that if we could just support, like if we could get another 20 African American PhDs, we'd have made a huge impact. So that costs a lot of money, but you're really talking 20, like you find 20 people out there that you can help. So that's very impactful. Or do you try and do a more across the board? So many people like to talk about there's a lot of people who even believe that the problem happens in middle school. I'm not sure the evidence supports that. It really does look like high school is still fine.
Mhm.
Um, so that Step Up program, which is working on the high school, is trying to take a really broad cut across high school. And so impacting, the point is if you can get to the teachers, you can get to a huge number of high school students. And so therefore, less money goes a long way because you're impacting, you're supporting individual teachers who then impact lots of students. So I guess I don't really have a favorite. Um, and I think partially if one is looking for where one can contribute, first thing is, this is the old saying about, act locally. So wherever you are is a good place to try to do something, even if it's just talking to your colleagues. Now, I can vouch for how frustrating that can be. That physics culture is very deep rooted. And, I've, the number of conversations I've had about, how do you improve searches so that that bias is just not affecting the searches? And there's really pretty well developed criteria for that. You develop criteria. What you don't do, which is what most people like to do, they say, you don't just listen, sort of look at a file and just decide, oh, I like this person. That sort of really gut instinct of this person is going to fit in really well is a really terrible way of doing this. For one thing, think historically where people for a long time would have concluded that women did not fit well into a physics environment. Black people did not fit well into a largely white environment. So fitting in is actually a pretty terrible criterion to use. I think more to the point, you pick criteria, pick any criteria you want for what you think makes a good faculty member or a good colleague. Pick those criteria, but then just use them. Don't just do this. I'm looking at this file and this. I have had colleagues who say to me things like, oh, we know excellence when we see it. And it's like,
Oh, yeah.
that's almost a stereotype. In fact, it is a stereotype of, that is a stereotype of we know excellence when we see it. I had a colleague, a woman actually, who finished that sentence by saying, and it just happens to look like us, so.
Yes.
So that's the local version is, do what you can and try not to get discouraged. Because it's a hard road. And then if one has the inclination, getting involved in some of these programs is a great way to do it. Joining for APS, join the Forum on Diversity, volunteer for the Committee on the Status of, they're still calling it Women in Physics, but I suspect that'll change somewhere in here, or it'll be W star
Mhm.
or something like that. But, APS is becoming increasingly conscious of the gender minorities. I mean, I think there's people who've always been conscious, but they're becoming increasingly conscious and attempting to support them.
Yes. So act locally.
Yes, act locally and look at
Don't
the
be a
website.
silent bystander, but
Right, right. Volunteer
be
for something at
involved
the
and
APS.
volunteer. Yeah, because we have to change somehow this curve and let it bend more
We
upward.
do, we do. We do.
Yes.
And consider
So,
what criteria you're using for searches and things like that. Like,
yeah.
if you continuously look for, the exceptional person, as opposed to looking for somebody who's made major advances, but perhaps by leading a collaboration, by, a more collaborative work. There's different criteria. I mean, there's things like, creativity. There's different things one can use, even if you're only looking at research. Somebody who's
Yes.
creative and imaginative. Yeah.
In fact, my university in Eindhoven is an example of this, because at the beginning of the year 2000 or a bit after that, there were no female professors, and now we have 25% because of a whole change in the system of
Yep.
of applications of
Yep.
describing posts and so on. So it really works out well.
So everybody on the phone call, if you want to hear more, talk to Marguerite, because I bet she can offer advice. It is known how to do better searches. That is not a great mystery. It is possible to do, and people are still choosing not to do it.
Yeah, yeah. Okay, well, I think we had all the questions from the chat. Is there something, what do you envisage, maybe as a last question, for the next 10 or 20 years? And what do you hope?
You mean in this field? You mean
In
as
this
far
field,
as
yeah.
gender? I guess I hope that we find, what concerns me, people ask me, what do I think we should do? And I keep saying, one of the things that I've realized is, I'm of the generation I'm part of. We had opportunities. This is not, there's an older generation that really had to fight battles.
Yeah.
So I can legitimately say I had opportunities. But I can also say that there were times I had to have very thick skin. Like I had to learn to be tough. And there are people in our field who say that being tough is a necessary part of physics. And they're correct, but that's not the end of that sentence. It is true, you have to be tough right now. You have to be able to, when somebody asks you an aggressive question in a talk, you have to answer it, and you have to answer it politely, and you have to, address it and things like this. But I would argue that, and I've actually talked to young women who say, that's wonderful that you're tough, but do you not understand? That makes me feel even less like I can make it, because I'm not that person. I know I can't be that person who can just stand up to that sort of criticism. So, so we have to be careful that we don't if we just try and replicate ourselves, maybe that's the reason or part of the reason that there's only 20%. We need to make it possible for people who are not tough. There's nothing that says that being tough makes you a better physicist. Right now, being tough lets you get by in our physics world, but it is not intrinsically true that that makes you a better scientist.
Yes.
So I guess that's my parting note, is that we have to make sure that we are doing our best to make it possible for people who are different than ourselves to be in physics.
To feel included. So there's a last comment of an anonymous attendee. I'm very thankful and proud of all that APS is doing and the visibility of these initiatives. In terms of acting locally, I always try to replicate that in the school. It's great to have that courage and inspiration. And I think you gave a very inspiring talk and a very inspiring answers during the Q&A session. So I really want to thank you for that as well.
Well, thank you, Marguerite. And I really enjoyed, I hope everybody enjoyed themselves and came away with a few thoughts. And
yes, I think people did, and thank you very much. Thank you very much also for attending this seminar. There will be a final seminar next Monday, and thank you very much, Francis Hellman, for this inspiring talk.
thank you, Marguerite. It was a pleasure meeting you too.
Pleasure meeting you. Bye-bye.
Bye-bye.